Hello, my name is Angelica Repolio. I'm the third reporter and I'll be reporting about groundwater and runoff movement for this episode. What is groundwater? Groundwater is the water found in cracks and spaces in soil and sand and rocks. It is the largest and most widely available supply of high quality fresh water for use. As you can see in the picture attached, this is an illustration on where to find groundwater. You can see the unsaturated zone in which it is the soil or the ground that we are stepping on. Below that is the water table in which we will see that it is quite wet because of the groundwater. Um, but that groundwater is not yet drinkable because it is not yet purified or it is not yet clean for us to drink. Um, beneath that is the large bodies of water in which those large spaces are being filled in by groundwater also. Take note, the amount of water that can be held in soil is called porosity, and the rate at which water flows through the soil is its permeability. Different surfaces holds different amounts of water and absorbs water at different rates. Groundwater is being replenished or recharged by rain and snowmelts. In some areas of the world, people face serious water shortages because groundwater is used faster than it is being replenished. In other areas, groundwater is polluted by human activities. Just like any other resources, when the resources are not immediately replenished or restocked, especially when the demand is higher than the supply, it will definitely dissipate faster. Groundwater is a good example for this. When the demand is high and it is not raining often, it has less chance of replenishing its supply, thus the water shortage. How do you determine the rate of groundwater movement? There are two types. There is the hydraulic conductivity, in which is a measure of a material's capacity to transmit water. It is defined as a constant of proportionality relating to the specific discharge of a porous medium under a unit of hydraulic gradient in Darcy's law, in which Darcy's law is V is equals to negative K multiplied to I, where V is specific discharge, K is the hydraulic conductivity, and I is the hydraulic gradient. The second one is the hydraulic gradient. It is the slope of water table or potentiometric surface that is the charge in water level per unit of distance along the direction of maximum head decrease. It is determined by measuring the water level in several wells. As you can see in the figure, the water level in the well is usually expressed in feet above sea level. It is the total head or HT in the left corner. You can see the total head or HT, in which it consists the elevation head or Z and pressure head HP. It is also the driving force that caused the groundwater to move in the direction of maximum maximum decreasing total head. Next topic is wells. We commonly know it as balon in Tagalog. So a well is a hole drilled into the ground to access water contained in an aquifer. A pipe and a pump are used to pull water out of the ground, and a screen filters out unwanted particles that could clog the pipe. So it is not usually seen here in the city, but it is very common in farming areas or like rural areas. They made wells to access the water ground on the ground below. There are three types of basic wells. The first one is the bored and shallow wells, which are usually bored into an unconfined water source, generally found at a depth of 100 feet or less. The second one is the consolidated or rock wells, which are drilled into formation consisting entirely of natural rock formation that contains no soil and does not collapse. Their average depth is about 250 feet. The third one is the unconsolidated or sand wells, which are drilled into formation consisting of soil, sand, gravel or clay material that collapses upon itself. Next topic is aquifers. An aquifer is a body of rock and or sediment that holds groundwater. An aquifer must be both permeable and porous and include such rock type as sandstone, conglomerate, fractured limestone, and unconsolidated sand and gravel. We can say that an aquifer is a container of water. The water contained in an aquifer can easily move, and it can easily transfer to one place to another. Examples of good aquifers are fractured volcano rocks, fractured granite, and fractured schist. As you can notice, it is all fractured because if the rock is fractured, it is more likely to be permeable and porous. What does an aquifer look like? Every aquifer is unique, although some are more generic than others. The boundaries of an aquifer are usually gradational into other aquifers so that an aquifer can be part of an aquifer system. The top of an unconfined aquifer is the water table. An confined aquifer has at least one aquitard at its top, and if it is stacked with others, an aquitard at its base. So this is what an aquifer looks like. There are two types of aquifers. The first one is the confined aquifer. A confined aquifer has water is trapped between two impervious layers. Water at any point in a confined aquifer is under pressure. Confined aquifers often are called artesian aquifers, and free-flowing wells frequently are said to exhibit artesian flow. So, as you can see in the water between the clay and the bedrock, the water is under pressure because it is being squeezed, or basta ka nang naipit. So basically, whenever you squeeze anything, it will create pressure, right? So when you excavate or bore a hole there, the water will rise because it has enough pressure coming from below. That is why it is free flowing. Just like springs or like in wells, diba, the water flows right above, upward rather. So the second aquifer is the unconfined aquifer. So unconfined aquifers has the bottom of the aquifer is an impervious confining stratum, and the top of the aquifer is open to the atmosphere through voids in the overlying geological material. The top of the saturated layer is called the water table, so an unconfined aquifer is known as a table aquifer. So unconfined aquifer, this is what an there, you can add in there. This is what an unconfined aquifer looks like. So the top layer is accessible to the atmosphere. So that is why the soil is saturated, because this is what we call the water table. So how does groundwater move? Groundwater moves slowly than water flowing down a river or stream. It moves mainly under gravity from areas of high groundwater level or pressure to areas of low groundwater level or pressure. In other words, it flows downhill. It is also possible for groundwater to move horizontally across an aquitard and even upwards when it is under very high pressure, known as an artesian pressure. So if groundwater moves, it depends on how strong the pressure is. It depends on the gravity and pressure of the water. So mas malakas talaga ang gravity pa downward, di ba? So the groundwater moves just like a water cycle. Paikot-ikot lang. So when gravity is much more stronger downward, so that is why the water is flowing downwards. Our next topic is runoff. So what is runoff? In hydrology, it refers to the amount of water discharged into surface streams. Interflow is water that infiltrates the soil surface and travels by gravity towards a stream channel and eventually empties into the channel. Runoff contains not only the water that travels over the land surface and through channels to reach stream, but also the water that infiltrates the soil surface and travels by gravity toward a stream channel. So runoff also involves groundwater discharge into a stream. Base flow, and also known as fair weather runoff, occurs where a stream channel intersects with the water table. So for example, it rained. So there is water coming from a mountain. So the example, the water is coming from the mountain. Coming down from a mountain. So if there is a slope, means there is a runoff. Slope plus water moving is equals to runoff. If the water from the rain was discharged to the stream or to a stream, it is also called a runoff because it is still flowing to the stream. As you can see there, the water is moving downwards to a body of water or a lake, a stream, or whatever. So it is called a runoff because it has a slope and the water is moving. So that is runoff. There are factors affecting runoff. First factor is the storm characteristics. This includes the type of nature of storm and season, intensity, duration, the areal extent or the distribution, the frequency, antecedent precipitation, and the direction of the storm movement. For example, this area experiences a low and short period of rain, and this area experience a strong and long period of rain. So this area may have stronger runoff than this area, right? So the second factor is the meteorological characteristics. This includes the temperature, humidity, wind velocity, and pressure variation. Third is the basin characteristics. This includes the size, shape, slope, altitude, or the elevation, the topography, geology, or the type of soil, land use or vegetation, and the orientation, and also the type of drainage net, and also its proximity to the ocean and mountain ranges. For example, it is known that trees help prevent flood. So if that area has many vegetations or many trees, it may also be a possibility. It has a likely great possibility that the runoff may be low or not as hard as the others without vegetation. So fourth is the storage characteristics. So the depression, pools and ponds or lakes, the stream, channel check dams or upstream reservoir or tanks, floodplains, swamps, groundwater storage of impervious deposits or aquifers, low intensity storms over long spells contribute to groundwater storage and produce relatively less runoff. That's all for my report. Thank you for listening, and I hope you have a great day.